Alright, what up everybody? This is Mr. Stan coming at you with another physics video. This time we're talking about a catch-up problem, where one thing catches up to another. Now in this specific problem, I'll read it. A deer runs at a constant velocity of 10 meters per second. A cheetah is at rest when he sees the deer run by. The cheetah immediately accelerates 2 meters per second squared. When does the cheetah catch the deer? So in this particular problem, one of the objects is moving at a constant velocity, and the other object starts from rest but moves at a constant acceleration. So the other object, the cheetah, is going to speed up faster and faster. The deer is going fast in the beginning, but it does not speed up. So when will the cheetah catch the deer is the question, right? And if both objects were accelerating, then this would be a little bit tougher problem. But because one object is moving at a constant velocity and the other object is accelerating, then these problems are easy, right? But you just have to know the trick. So let's see what happens. Right, so first of all, we'll make a graph. The information they give us is velocity information. They don't give us position information, and that's what we need because we want to know when the deer and the cheetah are at the same place. Okay, so here is their velocity. Okay, and I just use the information from the problem to make this. You'll see that the red line is a cheetah because it starts out at 0, meaning it's not moving in the beginning, and then every second that goes by, it gets 2 meters per second faster. Blue line is a deer. It starts out at 10 meters per second, and it doesn't change. It keeps on going at 10 meters per second. Okay, so when does a cheetah catch a deer? All right, well, some people might be tempted to say that it catches it right here where these two lines cross. Right, but remember, this is a velocity graph, not a position graph. So where these two lines cross, that means they're going the same speed. Does that mean that the cheetah has caught the deer? Well, no, because just because they're going the same speed doesn't mean they're in the same place, right? So what has to happen is their actual displacement has to be the same. And if you remember, the way that we find displacement from a velocity graph is looking at the area under the graph. So at any time, we can find the deer's displacement by finding the area under this blue line. And at any time, we can find the cheetah's displacement by looking at the area under this red line. Okay, the area under the blue line is going to be a rectangle, so it's going to be base times height. And the area under the red line is going to be a triangle, so it's going to be 1/2 of base times height. So wherever those areas are the same, that means their displacements are the same, which means they'd be in the same spot. So we have to find that time. We'll just start by looking at 1 second and what's happening at 1 second. So the displacement of a deer would be the area of this rectangle right here, the one that goes from 0 to 1 second. You can see there's a height of 10 and a base of 1, so 10 times 1 is 10, which means after 1 second, the deer has gone 10 meters. The cheetah, on the other hand, you would find the area of this triangle right here that's under the red line. And that's 1/2 base times height, which ends up being 1/2 of 1 times 2, which is just 1. So at 1 second, the deer is still way ahead of the cheetah. Okay. We'll go a little farther, right? And you could just find it at each second until they're the same, but we don't want to spend a lot of time doing it. So we're going to kind of skip ahead and see what happens. So at 5 seconds, you find the area under the blue line, and it would be and that would tell you where the deer is. And so that would just be the area of this rectangle here that goes from 0 to 5. So it'd be 5 times 10, or 50. And then that means the deer is 50 meters away from wherever it was at 0 seconds. Then for the cheetah, you have to find the area under the red line, and that's going to be a triangle, the same triangle that you see here going from 0 to 5. So that'll be 1/2 of 5 times 10, which gives you 25. So notice that even though they're going the same speed, the deer is exactly twice as far from where it started as a cheetah. Okay, and that's going to be important. Let's go ahead and skip all the way to the end of the graph, right? Because if it turns out that the cheetah has more displacement, then we'll just know that we went too far, and we'll try something in between. Okay, but we're not going to have to do that because you'll notice that the area under the blue line for the deer is 100, and then the area under the red line for the cheetah is also 100, right? It's going to be 1/2 of 10 times 20, which is 100, and the deer is 10 times 10, which is 100. Okay, so at 10 seconds, the cheetah and the deer are in the same location, so yummy. There is a trick to this. Okay, notice that the time where the cheetah caught the deer is exactly twice the time where they were going the same speed. Okay, so the deer started out going faster. 5 seconds later, the cheetah was now going the same speed. Right, 5 seconds after that, the cheetah and the deer are in the same location. All right, so if you know the time where they're going the same speed, you just double that time. That tells you when they're at the same location. All right, now there's a limit to using this method. Okay, for one, they have to be starting at the same time. Right, so you notice that the deer the deer starts at 0. The deer is going 10 meters per second at 0, and the cheetah starts at 0. If he had already been moving, right, and if he wasn't at rest at 0, if he was already going some speed, then this method wouldn't work. You could still find it by finding the areas under the graph, but you couldn't just double this time, right? And one object has to be accelerating, the other object has to be moving at a constant velocity for this to work. But with any regardless of whether it's this simple or not, with any problem, as long as you can find the areas underneath the velocity graph and those areas match, that means they're at the same place.